This video is going to be focused on the APT suite of tools, the Advanced Packaging Tool. So the first thing we're going to talk about is actually a concept, dependencies. We're not going to jump right in the specifics of the different commands, the different command line tools that make up the APT suite of tools. We are going to start by talking about the reason for which APT improve upon DPKG that we already discussed about. So to do so, I need to pretty much introduce the concept of dependency. To introduce the concept of dependency, I'm going to start with a quick hands-on demonstration. Here's the packages.ubuntu.com page for a package named Pingu. And Pingu is a game. Pingu is a little platform game inspired by a game known as Lemmings. For those of you who remember, those of you who have ever played that game, it's an old game now. So what is interesting about this game is that it has a list of dependencies as well, and more to the point, it has a list of dependencies that are not satisfied currently on this Ubuntu VirtualBox. So if I go to the architecture i386, I copy the link location to download the deb file, and then I go to my terminal, I can very easily download this deb file, just like I did with links-cur. Okay. There we go, the file should be here, there we go. Now I can do a dpkg install or -i and specify Pingu, and I can, of course, use sudo. And I can look at the result, and the result is errors while processing Pingus if we start from the bottom of the screen here. And if you look up, you see here that dpkg mentions that there are dependency problems that prevent the configuration of Pingu. And more to the point, it tells us what libraries are missing. Okay, and you can see it's libraries because it starts with a lib. So the lib SDL image 1.2, the lib SDL mixer, the lib boost signals, and then the Pingus data package also is not installed. So that means that to be able to install Pingus on this system, I should install all of those different packages one by one. And who knows, if I go and figure out that I want to install one of the packages, like Pingus data. Well, Pingus data doesn't have further dependencies that are significant. See, there you go. But others might have some dependencies, which I would have to resolve recursively by hand. So for example, here I clicked on one of the library randomly, lib SDL mixer 1.2, and you see that all those libraries are needed for this specific library to work, to be installable. So you can see how this is going to very quickly explode in terms of the number of pages I have to browse, and that every time I have to check that all those packages are on my system. If not, I have to make a note of it, and then I have to go back to the console and install them, etc., etc., etc. So dependencies, managing dependencies by hand is actually somewhat of a very, very awkward thing to do. Okay, I don't think anybody would like to do this. As a matter of fact, this is part of the reason of the success of Linux Debian, which has been known for this APT suite of tools, which is really, really good at managing dependencies. This is a reason for which, as I discussed in the introductory video, package management has become a very commonplace now. There are very great operating systems like Solaris that had a very poor, in my opinion, package management system, and since they switched to open Solaris, an open source release of Solaris, they have been immediately integrating tools to manage package more efficiently that were inspired by Linux. So bottom line is that everybody who is not yet doing this kind of package management is progressively converging toward this kind of package management, because it's just too problematic to manage dependencies by hand. The only thing really that you could do to try to alleviate this problem would be to actually embed inside your software all the library that you depend on. So let's take an example. Let's say that you have a game like Pingu, okay, and this game depends on, I don't remember the name of the library. I think it was lib SDL mixer, okay, and we're going to just assume that the libraries have names like this one, that are like a little easier to write down on this board, etc., and remember. So if we have a situation like that where we have a dependency like this, and the dependency is only on libraries, You can look at those libraries as pretty much DLLs. Okay, if we were under Windows, we would talk about DLLs. The idea of DLLs is that if I have inside my machine, if I have like two programs, let's call them P1 and P2, that are loaded in memory, and both of them depend on a DLL that we're going to call DLL1. Okay, this DLL, this dynamically linked library, needs to be loaded in memory only one time, and both programs can use it. What is the opposite of this? What is the old way of doing things before we introduce DLL? Well, the old way of doing things is, let me try to move this a little below here. The old way of doing things is to simply say that both P1 and P2 are going to have their own copy of the code for the equivalent to that DLL. So it would not be a DLL because it would be a statically linked library, but I'm just using the name DLL1 here and here to just show you that this is the same thing I'm talking about. So the code here of this dynamically loaded library would be pretty much built in the executable of P1, linked into the executable of P1, linked into the executable of P2. And now we have two programs that need to be loaded in memory, and each of them is using, I don't know, let's say that it's like a few kilobytes here of memory just to store that DLL. It's all fine and dandy if your DLL is small. If you have like 5, 10, 15, 50 DLLs that need to be loaded per program, and you have like 200 of those programs floating in memory at some point, you can see how this is wasting a lot of resource. I mean, this is especially true if you are like any sort of windowing system, desktop management system, and each of the program running a graphical user interface needs a bunch of libraries actually that are always the same. That is the library that are needed to create widgets and so on and so forth. So you can see how running a bunch of application under a Windows specific window manager windowing library is going to create a lot of redundant code being loaded in memory in each of the statically linked executables. Okay, so this is why DLL were introduced, to optimize a little bit this aspect of things. Now the idea here is that if we have dependencies like this to multiple DLL like libsdl, mixer, etc., we are in a situation where we can have a lot of problems emerging if we do not have a very efficient way to manage those dependencies when we install and when we remove software. So what kind of problems are we talking about? There's an interesting article actually on Wikipedia called Dependency Hell, and I really recommend that you read it. It's actually pretty well written as of today. You know that Wikipedia articles are not eternal; they can change in quality fairly easily. But this one, as of today, at least, like I said, is interesting to read. So take a look. Dependency hell. Okay, and I'm just going to give you two examples of problems that you can encounter with those dependencies. The first problem we are going to talk about, there are more on that page, but I don't think they are as relevant and as illustrative as the two that I've chosen. So the first one that we are going to talk about is conflicting dependencies. It's an interesting one. That means that you have a program 1 that depends on a library, let's call it library 1, okay, version 2.23, okay? And for some reason, if you have library 1 version 2.22 or 2.24, this program is not going to work. So no real backward compatibility here as the new release of that library come out. Program 2 depends on the same library, library 1 version 2.22. Problem. Okay, that's the first type of dependency problem. So in this instance, it's relatively easy to solve. At least modern systems are solving it relatively easily. The idea is that on a given system, you should be allowed to have multiple versions of a package, especially when that package is a library. But this is true also for entire compiler suites. For example, we can have the GCC compiler, we can have GCC 4.2 installed, we can have GCC 4.3 installed, and you are going to be able on the same machine to have multiple versions of GCC, multiple versions of the standard C library, for example, and use whichever you need to do a specific compilation task, okay, or use the library that you need for the programs that you are actually using. So generally, this is something that is resolved like this. Okay, we are going to enable different version of a library, different version of a software to coexist on the same system. Okay, so that's the first type of dependency problem. These are often referred to as conflicting dependencies. The second type of dependency problem that we're going to talk briefly about is often referred to as circular dependency. This one means that we have a software package, let's call it P1, that depends on a software package, let's call it P2, that depends on a software package called P1. And you can see the problem here. If I try to install with a tool like dpkg package P1, it's going to tell me I need to install P2 first. So I'm going to try to install P2, and it's going to tell me I need to install P1 first. So generally, you do not have this kind of dependency with only two software packages. You are going to have more software package involved. Let's say, for example, at least 3. Okay, that makes it a little less, how to say, obvious to detect like in this case, a mutual, codependency. In this case, you would have to look at the page for package 1, package 2, and then realize that it depends on package 3, and when you look at the page for package 3, you see that it depends on package 1. So this dependency, the circular dependency, can involve, an arbitrary number, an arbitrary large number of packages, just making them difficult to catch. This is probably, there are different options that you can try to leverage to resolve this first problem, but this one is really probably the problem that requires the most an advanced packaging tool, an evolved way of managing automatically dependencies and being able to force installation of some software package by delaying the verification of their dependencies so that we can install both P1 and P2 pretty much as if they were installed in parallel, denying the fact that we acknowledge that there is a dependency problem, and once both of them are installed, then they are going to function because they will find what they are needed. But we need to be able to manage the fact that there is a circular dependency here. So these are just two of the problems that we can encounter with dependencies. Dependency management is a whole topic on its own, but I wanted to give you an idea of the limits of dpkg, show them to you in practice, by using dpkg on the console, give you an idea of what the dependency problem is. And now we're going to talk a little bit about how to resolve this problem, which is pretty much what the APT tools are all about.